In this bonus chapter, we're going to explore procedurals. Procedurals are volumes that are generated mathematically, making them incredibly flexible and versatile. So in this chapter, we will learn the fundamentals of procedurals, how to render procedurals as meshes, and ways to combine them with other node families.
Hello and welcome back to Notch Content Intermediate course. In this chapter we'll talk about procedural meshing, and as you see we have quite a few setups to test out and to accomplish. So I propose that we just start with the first one, procedural meshing. So this is more or less the setting that we are after. I'm gonna enable the first layer, procedural meshing start, and let's talk a little bit about the nodes that we have here in the scene. So we have several nodes responsible for the lighting. So we have one spotlight here. We have skylight, which is lighting up the whole scene. We have fog scattering here for the background. And we have the shape 3D set to a plane, which is our floor. We have one camera that we're looking through now, and we have another shape 3D. This outline-based cube will be very handy for us because it will help us to define the bound box or the available space for procedurals. So with that said, let's start adding nodes. Procedurals, just like fields and just like particles, is quite a big system in Notch, so it has its own designated root. So if I type in root, you will see that we have a procedural root right here in the very bottom of the list. So just be aware that some naming conventions are similar in several systems, but we are referring now to the pink nodes, procedurals. Right, so we have a first node, procedural root. Now we need a couple of more. Let's grab procedural meshing. So procedural meshing is one of the available rendering nodes for procedurals. We're going to connect it to the procedural root. And we will grab another node. We will grab a generator. So if I go to procedurals and I expand the list of generators, you will see that there's quite a few to choose from. I think we're going to start with a very simple one, a 3D primitive. And here we are. Our initial setup is complete. So it takes 3 nodes to start a procedural system. You need a procedural root that contains the positional and scale data. You need procedural meshing, and procedural meshing is responsible for the rendering part of procedurals. There are quite a few options here in these panels, and we're going to cover them as we progress. And you need some kind of a generator. In this case, we've chose a 3D primitive as a first generator in the scene. Again, as you see, we have quite a few to choose from. So let's start with the 3D primitive. 3D primitive, just like shape 3D, contains quite a few shapes to choose from. Now, one thing to keep in mind when working with procedurals, they are existing in a specific space that is bounded by either a renderer, in this case procedural meshing, or external bounding box. We don't have any external bounding boxes for this setting just yet, but we will add it as we progress. Right, I'm gonna hit 5 and I'm gonna pan out from the active rendering camera, and if I'll turn around the setting, you will see that we have 2 little holes here on this 3D primitive. So these 2 little holes on the sides indicates that we are hitting the bound box of available space for procedurals. So if I was to make this sphere even bigger, you will see that all of a sudden these holes are becoming bigger and bigger. Procedural meshing node contains properties that allows you to seal these cuts. We will cover that once we are talking about procedural meshing. So let's carry on with the 3D primitive. I'm going to make this sphere a little bit smaller. I'm going to hit 0 to come back to my active rendering camera. And I'm going to make a copy of this 3D primitive. And I'm going to connect it to the procedural root. At the moment we have 2 3D primitives. They are rendering on top of each other and they look exactly the same. That's why we don't see the second one. So I'm just going to offset the second one, the new one a little bit to the side. In fact, I'm going to give them both a little bit more space. I think I'm going to make them smaller. We might as well give ourselves a little bit more space here for the node graph. So I will decrease the viewport and I'm going to expand the space here. So now we have 2 3D primitives on the screen. I think this is a good time to talk about CSG mode. So CSG mode stands for Constructive Solid Geometry. People coming from Cinema 4D background might be more familiar with the term Boolean operations. So in short, CSG modes are blend modes for 3D objects in procedurals. As you see, we have quite a few to choose from, and you are probably quite familiar with blending modes in a 2D world, where you can blend, subtract, multiply, or set other various blend modes. Let's make sure that we have bottom 3D primitive selected, and let's just choose another type of CSG mode for it. As you see, as I'm progressing, I'm gonna make sure that we're in a orb view so we see better what's going on. As I'm progressing through different options, I see different behavior in these two shapes. So either they subtract one from the other or intersect, in this case making this shape of a pill, or for instance they form one unified object. So I think I'm going to stick with the smooth union for now. So with the smooth union selected, all of a sudden I have a blob on the screen. That's great. We can further tweak properties of this blend by changing CSG blend weight. So we can either reduce it or increase it depending on what we are trying to achieve. Well, let's set it to a little bit bigger property here, so maybe 1.2. Generator stacking order is very important. Just like working with post effects or other systems in Notch, Notch recognizes the stacking order from top to bottom or from left to right. So just keep that in mind when you're working on your setting and you're changing various CSG modes. So it's always going to work from top to bottom. Okay, let's add another type of generator. Let's try fractal noise. I'm gonna grab fractal noise from the list. Now mind you, we're using the pink fractal noise. You might notice that there's quite a few fractal noise nodes available in the node list. We want the pink one. I'm gonna connect it to the procedural root. And here we are. As soon as I connect it, I see it's rendering. So I think I'm gonna lift it a little bit higher up. I'm gonna add some iterations to it so it's a little bit more detailed. And I'm gonna decrease the distance offset. And as you see, fractal noise has some fractal modes. So let's see if, let's say, a second option, 3D noise, looks a little bit better. Actually, I think it does. I find this a little bit more elaborate and interesting. In fact, I think it changed so drastically that I'll have to bring it a little bit down. Yeah, maybe something like this. Great, I think this works. The reason why I added this fractal noise to the scene is just to further showcase the CSG modes. In this case, I think I'm going to set it to intersection. All of a sudden we're intersecting these two 3D primitives with the fractal noise. So if I change the fractal noise position, you will see that we are altering the looks and state of the available 3D primitives. In fact, we might as well give a bit more detail. So I'm going to set it to 6 here. Skylight is a little bit harsh here on this shape. I think this is a good time to add a material node and tweak material's brightness property. So I'm going to grab a material node. Material node has a designated input in the procedural meshing, so it's always connecting to a renderer. In this case is the third input here, material. And if I grab the output, you will see that that specific input lights up as a plausible hookup point. Right, so now in the material, I'm just going to decrease the brightness a little bit. There we go. This looks much better already. I think now it's a good time to talk about a procedural meshing node. I'm going to pan out from the active camera view and I'm going to go into orb view. So you have noticed that there's some tears in our model here. How can we address this? How can we make this smoother and more coherent? Well, we can set all of these properties in a procedural meshing node. Here we can increase or decrease the density of the procedural system. So the default is 256 on width, height and depth. So let's see how this looks in the wireframes and let's add a little bit more points to this setting. There we go. So by increasing the width, height and depth iterations, we're adding more detail to our procedural system. Now, in this case, I don't think it's actually needed and it's quite costly on your GPU performance. So I would recommend to keep the width, height and depth in a default setting of 256 by 256. You might have a reason to change it in your own personal projects, but for the sake of this workshop, we're gonna keep it in the default. So if you end up having some undesired cuts in your model or some inconsistencies, error tolerance helps out with flushing them out. So I'm gonna straight away set it to 10. It didn't really change much in this setting just yet, but it will be visibly handy when we progress through other workshops. Smoothing iterations. This is exactly what will fix these tears. So as I'm progressing that, as you see, things becomes smoother and slicker. I'm gonna set it straight away to 10, for instance, or in fact, 20. There we go. Looking much better already. So now I'm going to grab this 3D primitive and I'm going to make it bigger. We've already spoken about this a little bit, the cuts in the model or the cuts in your procedural mesh. So how do you seal this? I mentioned that you can do that in the procedural meshing node. So let's just go into the settings of procedural mesh and find an option called seal boundaries. As soon as we enable seal boundaries, we are closing these gaps. We are closing the walls of our available procedural space. Procedurals are not bounded in this space. You can actually expand it if you need it. You can always add a bounding box node and connect it to the procedural root. As you see, there's an input here on the left hand side, and if I press on the output of the bounding box, it lights up. So this is exactly where we can pipe in a bounding box and expand it to our needs. So now we definitely have more space for our procedurals to generate. Now, mind you, as you're expanding the available space for procedurals, you are losing density. So I would recommend increasing the width, height, and depth as you give more space for your procedural world. And again, increasing the width, height, and depth will put a bigger restraint on your GPU. So just be aware of these numbers as you progress through your procedural work. Right, I'm going to delete the bounding box. We don't necessarily need it here for this setting. And I think I will delete this 3D primitive and fractal noise as well. I'm going to leave just this 3D primitive. There is one more generator that I would like to talk about in this workshop, and that's a 3D object. So I'm going to grab that from the list and I'm going to connect it to the procedural root. So what's the difference between the 3D primitive and 3D object? So 3D primitive contains shapes of its own in a primitive type, and 3D object allows you to bring in any 3D model from your library, from your resources, and pipe it to the procedural system. I have one model available for me here in the resources, and that's looking around. So I'm going to connect it to the root, and I see that this is a model of a human in a static T position. So I'm going to make sure to make it animated by choosing another animation set. There we go. It's definitely working. And now it's time to connect this imported 3D scene to the 3D object. Now notice, if I grab the output of the imported 3D scene, the plausible hookup point object node does not light up. And that is because this imported 3D scene has a little bit more information than just a 3D mesh. It actually has a whole bone structure and bone animation. So for us to be able to pipe the imported 3D scene to 3D object, we need to use exact geometry. In this case, this CH36 node. There we are. Now the hookup is complete. All we have to do is make sure that this model is in the bounded space of our procedurals. And as I move it into the procedural space, it's definitely starting to render. That's great. In fact, I don't necessarily need to see this model anymore. I only want to see the procedurals. So I'm going to go to the imported 3D scene and I'm going to set visibility to 0. So I set the visibility to 0 and I started the playhead, and I see that there's no motion in the scene, although I'm certain that there's animations running in the FBX model. So why don't I see any animations in the procedurals? Well, that is because in a 3D object I have to activate the animate SDF property. As soon as I do that, procedurals starts to move in accordance to animation given by the 3D model. So I'm going to set it back to invisible now. So let's talk a little bit about the quality of this mesh. First of all, I think it should be a little bit higher up so we see the feet of this guy. There we go. And as you see, we don't have any details of the fingers. They're sort of lost. And that is because we have a rather low SDF width, height, and depth. So when it comes to imported 3D objects, you can actually choose the density of your imported 3D model. The default is set to 128 on width, height, and depth. We can actually increase that. But before we do, I will disable the smoothing iteration so we see the exact model as it is. So this is the model in iterations of 128. And let's set it to 256 on all three properties. There we go. All of a sudden we have finger details. Now you will see if we bring back the smoothness, we're losing the finger information. Since I don't really care about the fingers for this setting, I think I'm going to retain the smoothing iteration set to 20, and I'm going to decrease the SDF width, height, and depth to the initial setting of 128. There we go. Let's put this model in the center of this procedural meshing. And I think I'm going to make this 3D primitive smaller. So these two models are interacting, but I think we should make them collide smoothly. So in a 3D object, I'm going to set the CSG mode to smooth union. Let's see if we can change the blend weight. Yeah, maybe something like that. There we go. I think I'm going to add one more 3D primitive. And I'm gonna set it to the smooth union as well. I'm gonna set this to torus. We haven't tried torus just yet. Let's make it smaller. Perhaps let's rotate it and position it somewhere here on the side. You could make do with a bit thicker inner radius. All right, let's set it to smooth union. Right, so now we have a couple of 3D primitives and a 3D object. Now, as you see, this 3D object has a whole bone structure. So what if I want to attach a 3D primitive to, let's say, a head bone of this mesh? Well, I'll just move the head bone a little bit closer to the rest of the procedurals. I'm gonna make sure that everything else is a little bit lower. And now I'm gonna grab a new 3D primitive, connecting to the procedural root. Double click on the 3D primitive, and let's say I'm gonna set it to torus again. As you see, the first property here in the 3D primitive is transform modifiers. This is exactly where I can hook my head bone to alter and transform the positions and rotations of this primitive. There we go. All of a sudden, this 3D primitive is following the positional and rotational values of the head. Now, if I want to reduce the scale of it, as you see, it's not responding. And that's expected. For us to be able to further tweak the scale or rotations of the 3D primitive, we have to add a geometry null in between the bone and the primitive. So I'm gonna grab the geometry null. I'm gonna unhook this link. So head to the null, and from the null to the first input here, transform modifiers. Again, we found the transform modifiers as a first option as we double clicked on the node. So now with this null available, I can actually tweak the rotations and scale values as I please. There we go. So this setting is starting to look a little bit better. I think the next step is to give this model a floor. It would be nice if it was standing on something. So I'm gonna grab yet another primitive. I'm gonna connect it to the procedural root, and I'm gonna set it to a box. Now I don't want this box to fill the whole space, so I'm just gonna turn it a little bit lower. There we go. And I'm gonna set it to smooth union. Let's increase that blend weight. We could make this floor a little bit more dynamic if we added some fractal noise to it. So with that done, this floor would look a little bit more like terrain. So I'm grabbing fractal noise. I'm gonna connect it to the procedural root. And I'm gonna give more iterations to it. So maybe 6. Great, let's choose 3D noise in the fractal mode. Yep, this works. Maybe a little bit less gain and a little bit less distance offset. And now we'll move the whole fractal noise setting lower so it's closer to the floor. In fact, I could probably animate this property with a continuous modifier spinning around the heading property. I think I'm gonna go ahead and do that. It's rather slow. I'm going to give a little bit more speed. So I'm going to set it to 10 on the speed property. Now, I'm not necessarily happy with the fact that we're bound in the shape of a cube. We could easily be bounded in the shape of a sphere. For that, again, we will need a primitive. We will connect it to the procedural root. And as you see, this 3D primitive is filling the majority of available space. So let's change its CSG mode from union to intersection. So all of a sudden, every single node that is stacked prior to this 3D primitive is being intersected by it. That's great. One more thing that we could alter here is the material. We could make it a tiniest bit more exciting, as now this model is just gray. So I propose we use something for the color channel. A good choice here would be some kind of a generator. I think I'm going to go for fractal noise as a generator for the color texture. Right, so I'm connecting the fractal noise. Let's shape it a little bit. I think I'm going to give it a bit more scale. So I'm going to set the width and height to 1024 by 1024. And I'm not necessarily happy with the FBM noise type. I'm going to choose something else, maybe warped 3. Good. It's quite fast. We could slow it down. Yeah, this is much better. How about a bit bigger amount so it looks a little bit more bright? Let's give it more threshold. We don't necessarily want those light grays there at all. Right, I think this works. Let's see. So we connected the fractal noise to the color channel, but it doesn't really look anything like what we have here in the actual generator. And there's a good reason for that. Procedural meshing does not generate UV maps, and Notch requires UV maps to know exactly how should it wrap a texture around the model. So to address that, we have a node called mapping. Mapping node works directly with the material, and it has a designated input, and that's the last one here in the chain, second in a row after the first one, so mapping. As soon as we apply mapping node, you will see that we have a very different look to our texture. In a mapping node, we have several options. We can choose mapping type, so planar, cubic, spherical, quite a few others. I think we can stick around with the planar. And then we have source channel. Should it be world coordinates or local? So I'm going to go for local. Mapping node is applicable for all imported 3D models or 3D primitives. You might find yourself in a situation where you just need to redo, or you want to overwrite the available UV map. This is pretty much your best friend, the mapping node. Right, so there is one more thing that I want to change here. I want to have some environment map reflections in this setup. So I'm going to go to material, enable the environment map, and I'm going to make sure to increase specularity. That looks okay, but I think we can make something a little bit more interesting. So I'm going to reset the specularity. And I think I'm going to use the same fractal noise to drive the roughness of this setting. So basically, I don't want any reflections where we see the white color, but I definitely want a strong reflection where it's black. So I'm going to grab the fractal noise and I'm going to pipe it into the roughness input right here in the material. There we go. So now I can come back to the material, increase the roughness and increase the metallicness. And as I'm doing that, I see that now I see reflections only where I have the black space, and where it's white, it's completely rough. That's great. That's exactly what I wanted. So this is the fundamentals of procedural meshing. You can use 3D primitives or imported 3D models or any other generator out of the vast list available to make some intricate designs. The big takeaway here is different blend modes in all of the generators. Every single generator has CSG modes available. And by using CSG modes, you can achieve some really, really interesting designs. So a couple of things to remember about procedural meshing node is the fact that you can change the width, height, and depth. So basically you can increase or decrease the density of your mesh. You have control over error tolerance and smoothing, and you have a property to seal boundaries if you find yourself hitting the walls of your available space of procedural meshing. Now, if you need to extend that, as we've spoken, you can use a bounding box node and you would connect it here to the left-hand side of the procedural root. I think I am done tweaking this setup, but feel free to explore it further by adding more generators and by changing their CSG modes. And once you're ready, I will see you in the next workshop where we're going to talk about particle system connectivity to a procedurals. So take your time to finish this setting, grab a coffee, and see you in the next workshop, Procedurals and Particles. Welcome back to Content Intermediate course. In this workshop, we're going to talk about connecting particles to procedurals. So this is more or less the finished setup that we're after. So I'm going to enable the third layer Procedurals Particles Start, and I'm going to introduce you to the nodes that we have here in the node graph. So here at the very top, we have a fog scattering for the background. Skylight and environment map nodes are responsible for the main lighting. We have one spotlight. We have a camera that we're looking through, and a shape 3D set to a plane, which serves as our floor. Here at the top, we have another shape 3D, which is set to a box setting, and it's made invisible just with the outlines marking the bounds of our procedural space. So by now we are familiar with the basics of the procedurals. We know that we need 3 main nodes to set up the initial setup. We need a procedural root, procedural meshing, and a generator. In this workshop, we'll use particle generator. And as you see, we have 2 options. We're going to try both of them and we're going to discuss the differences between one and the other. But before we talk more about procedurals, let's build a small particle system. I'm going to start by adding a root. So here is my particle root. I'm going to grab a primitive emitter. There we go. I think we will need some kind of a motion in particles, so it would be a little bit more dynamic. I'm going to go for vortex. There's the vortex effector. And while we're building the particle system, even though we're going to translate it to procedurals, I think it's wise to add a point renderer as a reference. So I'm going to add point renderer. There we go. Now, if I start the playback, I see that it's rendering, it's working, that's great. Now for our sample here, we don't necessarily need that great many particles. So in the particle root, I'm going to decrease the numbers to 64, and I'm going to match that specific number here in the primitive emitter. So I'm going to set it to 64 on the max particle count. I think the vortex is a little bit too fast, so I'm going to reduce the velocity. So let's set it to 0.2. And this is more or less a good enough particle system for us to translate to procedurals. In fact, before we build a procedural system, perhaps let's change the direction of the vortex. Let's make it go from left to right. There we go. Great. So let's start with the procedural system. First of all, we need a procedural root. Now let's add a renderer, so procedural meshing. And now we only miss one more node, a node that would connect those 2 systems together. Again, as mentioned before, we have 2 options. We have particles and particles as primitives. I'm going to bring them both to the node graph, and let's talk a little bit about their differences. So depending on the simulation you are building, you might want to choose one or the other. Particles node is best fit for a vast numbers. When you have a simulation that runs with several thousand or hundreds of thousands of particles, this is probably the best choice. Particles as primitives has more options and it's a little bit more complex. So when you're aiming for more refined, more elaborate designs, this is probably a better choice. I'm going to use them both and you'll have an option to see how they behave and what are the differences. So let's start. First of all, I'm going to connect a procedural root to the particles node. And now as you see, we have 2 inputs here in the bottom. One of them is marked gold with a statement that it's required. So we need to connect either primitive emitter or particle root for this particle system to correspond with the procedurals. Now the reason why we have an option to choose either the root or emitter is because perhaps we want to use a specific emitter to drive this procedural node. Hence we could have several emitters and they could be connected to different particles nodes in procedurals. So with that said, I'm going to start by connecting particle root and then I'm going to switch for the primitive emitter. There we go. So we've started simulation and it's definitely working. It doesn't really look that good just yet, but we can address several settings to make this look much better. So let's start with the procedural meshing settings. I think we definitely want to increase the error tolerance because I see that there's some splits and gaps. So this will fix that straight away. So I'm setting it to 10 and I think this could be smoother. So I might as well put the smoothing iterations setting to 20. Yes, this is looking way better. In fact, I think I could easily tick on seal boundaries because very likely some of the particles are just cutting on the sides as the primitives were in the previous workshop. Right, so let's check out a couple of settings in this particles node. I see that I have control over the particle size, so perhaps I would make them smaller and I can actually make them random in size. In fact, I don't really want them to be spheres, so I'm going to choose blobs instead. Let's make them a little bit bigger. So this is the particles node for the procedurals. Let's swap this node with the particles as primitives and let's see how that looks. I'm going to disconnect. And I'm going to connect this node instead. So I'm connecting it to the procedural root and I'm piping the particle root to the first input for particles as primitives. So here we have more control of how the actual particle looks. In the Particles node, we could choose only from blobs and spheres. Here we can actually choose from quite a big number of primitives. I think I'm going to leave it at the setting of torus. I think it would be interesting to use both of these generators together at the same time. So I'm going to connect the particles back to the procedural root. I'm going to disconnect particles as primitives from the particle root. And now I'm going to split the looks and the operators by connecting them directly with the emitters. So I'm going to move these two nodes to the side. I'm going to make a copy of the primitive emitter. And now I'm going to use the first emitter for the particles as primitives and the second one for the particles node. Obviously, I want to split their behavior as well. So I'm going to attach the vortex to the first primitive emitter. And I'm going to bring something else for this one. So perhaps curl noise fluid effector. Let's see how that looks. Let's maybe reduce the simulation speed and increase the curl amount. Let's make that noise size smaller to 0.3. In fact, we have 64 particles to go around 2 emitters, and they're both asking for 64 particles. I think we should split that number because there's just not enough for them to share now. So I'm gonna set this one to 32 and the other one to 32 as well. I think my curl noise is actually going a little bit further out of the bounds that I would like it to go. So I'm gonna reduce the radius. Maybe a little bit more. There we go. Now it's definitely in the bound box of our procedural system. Cool. I don't think we actually need this point renderer anymore. It was there just as a referral. So I'm going to disable that. So I think I'm going to start by connecting the first primitive emitter to the particles, and then the second one to the particles as primitives. So now we have both of these generators working at the same time. In fact, we could make sure that they have some kind of a connection in between them. We could set the bottom generator particles as primitives to a CSG mode smooth union. Skylight looks a little bit harsh in this setting, so I think I'm going to bring in a material node. And I'm going to connect it to the third input of the procedural meshing material. Now I can tweak the brightness or color parameter and just make it a little bit dimmer. In fact, I think I'm going to enable the environment mapping so it becomes a little bit more specular. Let's bring up the specularity. I'm going to make sure that we see nodes a little bit better, so I'm just going to spread them out. There we go. So one more setting that would be handy to mention here is coloring the particles. In the particles as primitives, we have a property for the material color. But if I set it to any color at all, it doesn't look like it's working. And that is because we have to first enable use particle colors. And then we have to make sure that generating colors is enabled in the procedural meshing. As soon as we enable the generate colors in the procedural meshing and we choose to use particle colors, we can control the color of the particles. So maybe let's set it to the light blue. Now let's check the particles node. I see that there's a property for effect colors. Let's stick that on. And let's choose another color for the particles node. So using particle systems with procedurals is rather straightforward. You have two options for two different generators. Depending on what you're building, you might want to choose either the particles or particles as primitives. Important thing to remember when you're changing the color of the particles, make sure to enable it in the generator and in the procedural meshing. Take a moment to explore the setting, and once you're ready, let's get back together for the next workshop where we will talk about procedurals and clones. Welcome back to Content Intermediate course. In this workshop, we're going to talk about procedurals and clones and how do we connect them. So here we have a more or less finished setup. This is what we are after. I'm going to enable the fifth layer here, procedurals, clones, start. And let's get going. But before we actually add any nodes, let's just talk about the nodes that we have here in the node graph. We have several nodes responsible for the lighting. So we have fog scattering for the background, one spotlight here at the top, skylight and environment map working for the general lighting. We have a camera that we're looking through now, a shape 3D set to a plane, which is working as a floor for us. And here at the top, we have one more shape 3D set to a box, which is rendering only the outlines of this primitive, so we could see where are our bounds for our procedural system that we are to build. Right, so let's start by building a small procedural system. I'm gonna add a procedural root, procedural meshing, and several 3D primitives. There we go. So this is my first one. I think I want this a little bit smaller. And I'm gonna make a copy of it. I'm gonna connect the second one beneath it. Let's move the second one a little bit higher, and perhaps let's set it to a box. I'll make it smaller still. I'm gonna change the CSG mode from union to smooth union. So my goal here now is to build a little abstract shape that we can send to cloner system. So having a box here will definitely look good. Let's see if we can add a little bit more blend weight. I'll make another 3D primitive, and I think I'm going to set this one to a torus. And I'm going to move it downwards. Let's rotate it. Could be bigger. Perhaps it should have a little bit bigger inner radius. There we are. Perfect. Let's change a couple of things in the procedural meshing. I think I want to make sure that it's a bit smoother, so I'm going to add some smoothing iterations, perhaps 20. And I'm going to make sure to seal boundaries just in case. There we go. So here we have our procedural system, and if we want to express it as clones, all we have to do is find the corresponding cloner that could read this information. So I'm going to go for clone to procedurals. I'm connecting it to the root, and now I have several inputs here in the bottom. As soon as I hover over the first one, I see that the procedural root lights up, and the name of the input indicates procedural root. So I'm going to connect the procedural root exactly there. Now for cloner setup to be complete, cloner needs to have an operator to output. So let's give it a shape 3D. I already see that we are spawning clones on top of this shape. I think we could make the clones a little bit bigger, so I will increase the clone scale. Great, this definitely works. I think I'm going to add one more operator. So I'm going to copy the shape 3D, connect it to the clone to procedurals, and I'm going to make sure that this one is set to a box. So now they're iterating one after the other, and that is because the default setting in the clone to procedurals is node spawn mode iterate. I'm gonna go for random. I bet this setup would look much more interesting if these clones were dynamic, so I'm gonna add some turbulence as an effector. Let's stick on uniform scale, and let's just make sure that they are going up and down in scale. It's a little bit fast, so I'm going to reduce the animation rate. In fact, we don't need to see the procedural system anymore, so I can come back to the procedural meshing and set the visibility property to 0. So now we only see the clones being rendered in the shape of this procedural design that we made. So I think there's one more setting that would be interesting to enable. It's a rotate clones by normals. This makes things a little bit more dynamic, a little bit more interesting. I think I'm going to add a material node here, and I'm going to share it amongst these two shape 3Ds. I want to enable environment mapping, and I want to have a little bit of reflection on both of these shapes. Right, maybe let's reduce the brightness a little bit. And perhaps let's give it a bit more turbulence, so it's that more dynamic. In fact, we could add a couple of more effectors. I'm going to go for a randomize effector. There we go. Let's connect it to the second input effectors. Let's tick on uniform scale. And let's reduce the size further still. I think I'm going to change the box setting to a cylinder. Or perhaps capsule. There we go. Let's add one more effector, maybe sine effector. And in the sine effector, let's change the rotation pitch. And let's see if it would look nicer if we would change the direction from linear to, let's say, radial. Yeah, I think this is much more exciting than it was before. It would be nice to have a little bit of colors here. So I'm going to add one more effector. Color ramp effector. Now, color ramp effector doesn't work on its own. It requires a color ramp to fulfill its task. So I'm connecting color ramp to the first input, color ramp. So let's make sure that one color is set to maybe light blue and the other one to perhaps, let's say, pink. Right, so now in the color effector, I can actually choose the way the colors should be distributed in this setting. I actually quite like the looks of the distance source channel distribution. I'm gonna make sure that there's just a little bit more of blue. So let's recap what we've built here. Basically, we built a very small procedural system using several 3D primitives. Then we make sure that we do not render it on screen, and then we send it to a clone to procedurals node, where we use two operators to render it. So a shape 3D set to a sphere and another shape 3D set to a capsule. We added several effectors for the dynamics, so we would animate, and we have applied a material node on both of these operators, just so we would have a little bit more of a reflection of the environment map. Feel free to push this setting further, and once you're ready, let's meet in the last workshop of this chapter, where we will be connecting procedurals to field system. Welcome back to Content Intermediate course. In this workshop, we're going to talk about rendering fields in procedurals. So this is more or less the setup that we're after. So with that said, let's just head to the procedurals fields start, and let's talk about the nodes that we have available in the node graph before we start building the setting. So here on the left hand side, we have several nodes responsible for the lighting. So we have skylight and environment map working together, lighting up the whole scene. And right next to it, we have one spotlight. Fog scattering fills the background. And here in the bottom, we have shape 3D set to a plane for the floor. We have a camera. We're looking through this camera right now. And a little bit higher up here, we have a shape 3D set to a box, and we are rendering only the outlines of this box. This box is a very good referral for us for the bound box of the procedurals, and in this case, even fields. So with that said, I think we're ready to start. And since we're planning to translate fields to procedurals, I think we should start by building a field system. It's not going to be very complex, but we definitely need to add some nodes. So let's start with the field root. As you already know, field root comes in as a quad, so width and height is set to 256. We need to match all these three numbers if we want to have this in 3D space. So I'm going to set it to 100 by 100 by 100. So now we need an emitter. So I'm going to go for the primitive emitter. Let's grab a renderer. And with these three nodes in the node graph, we can actually start the simulation. I see that we have this shape of a coin. That's good. That was expected. In the primitive emitter, let's change it from a circle to a sphere. And now let's add some kind of a motion or behavior to this field system. Let's start with the curl noise effector. There we go. It's definitely working. It's a little bit too active. I think I'm going to reduce the noise size. This could be something like 0.2. Let's restart the playhead. Yep, this looks good. Perhaps a little bit of turbulence to make things a tiniest bit more dynamic. We don't need a lot of velocity here, so maybe 0.2. And let's add a lot of noise. I'm going to set it to 8. Let's see. Yeah, this looks rather alright. There's quite a bit of detail. There's things happening. Perhaps let's just change the rotation so it goes upwards. Alright, I think this is more than ready to be translated to procedurals. So let's focus now on the procedural system. I'm going to start by adding a root. That is a mandatory node for all the procedural systems. And since we're talking about procedural meshing, we need that node in the node graph as well. So this will be our renderer. There we go. And now if we look to the list of generators available, you will see that there's a level set field. So the only way for us to connect a field system to procedural system is via using a level set field. Now, if I was to try to connect a level set directly from the field root now, let's just make sure that it's actively running with the procedural root, you will notice that it is just impossible. And that is because we need to swap out the field root to the field level set root. And that is a rather easy operation. All we have to do is right click on the field root, replace node with, go for the fields, and find the appropriate node, in this case field level set root. So the looks of the fields changed, and that's fine, that's expected. Now we're rendering fields to level set, and we can interpret that via procedural. So if I grab the output of the field level set root, you will see that the input lights up. So let's just connect that. There we go. In this case, we don't need anymore the field renderer, so I'm just going to disable that. Let's restart the playhead. So by exchanging the regular field root to a field level set root and connecting it to the level set field node, we are actually rendering this smoke simulation as a mesh. Now there's a couple of things we might want to change in the procedural meshing node. I think we definitely want to bump up the error tolerance and add some smoothing. So I'm going to add 20 there. Great, I think this works. Now to make things a little bit more interesting, I propose that we take this procedural system and we convert it to clone. So I'm going to grab clone to procedurals node. I'm going to connect it to the root and I'm going to send this procedural system to clone to procedurals. Obviously we need some kind of a operator as an output for the cloner. Here we are, let's make those clones a little bit bigger. Okay, let's push this a little bit further. In a previous workshop, we've hidden our procedurals. In this one, perhaps let's just make it see-through. So I'm going to grab a material node. I'm going to connect it to the procedural meshing, and I'm going to enable the environment mapping. There we go. Let's perhaps make it a bit more specular. Yeah, now I start to see the little specks here and there on the mesh. That's good. And let's change the alpha mode of this material. And so instead of alpha mode opaque, I'm going to go for alpha blended, and I'm going to set it to additive. Okay, perhaps the clones are a little bit too big, so I'm just going to reduce the scale. This is a bit better. I'm going to come back to material and see if I can make this see-through material pop out a little bit more. Right, we might as well give it a bit of color, so perhaps something warm, and let's just increase the specularity quite lots. We could enable the rim lighting as well. Let's see if that helps. Yeah, that helps a little bit. In fact, specularity could be a little bit darker. There we are. Right, so now we could add some colors to the cloners. So let's go for color ramp. There we are, color ramp effector. Now, color ramp effector requires an actual color ramp to fulfill its task. So let's add that, and let's choose some colors. Let's see how do we want to mix them. Yeah, we could go for fractal noise. And I think we could reduce the noise scale a little bit. It's rather fast. I'm going to reduce the speed as well. In fact, the shape 3D that we are using with the clone to procedurals, that too could have a material and a little bit of reflectance from the environment map. The clones could be random in scale, so let's do that. Let's add a randomize effector. I'm taking on uniform scale. I'm just going to make sure that some of them are a little bit smaller so we see better the actual field. Well, here we are. In a matter of several minutes, we took a field system, we rendered it out as a mesh via procedural meshing, and then we expressed it as a clone inside of the see-through material. Okay, I think I'm going to stop here and I'm going to allow you to explore procedurals further on your own. Now, you have a lot of options and possibilities here. You can add more effectors to the field level set system, or more generators for the procedurals, perhaps more operators for the clone to procedural setting, or effectors. Possibilities of altering the setting is practically limitless. And I think this is exactly what makes procedurals so fun in Notch. Every system that we have here in Notch can mix and intertwine, creating some really interesting, really outlandish settings. I'm excited to see what you build using procedurals. So thank you very much for watching Procedural Meshing Fundamental Chapter, and I hope to see you in upcoming courses.